So the first thing we have to remember is a rectangle is a quadrilateral. It has four sides. It is a parallelogram. We ready? So that means it has all of the properties of a parallelogram. Okay, so the first sentence, rectangles have the same properties of a parallelogram. Those are listed right there below that statement. Opposite sides are congruent. The same thing happens in a rectangle. Opposite sides are parallel. Same thing happens in a rectangle. Opposite angles are congruent. Same thing happens in a rectangle. Consecutive angles are supplementary, and the diagonals bisect each other. But there are a couple of extra properties that are specific to rectangles that we also have to remember. Okay? The first is first of all, how many angles are in a rectangle? 4. Okay. So all 4 angles are what kind of angles in a rectangle? Right angles, yes. You can see it in your picture too. They are all marked with your little right angle boxes. Okay. All 4 of your angles in a rectangle are right angles. And the other property specific to rectangles is that the diagonals are congruent. Not only do they cut each other in half, they're also congruent. Okay, so with a rectangle, all of the properties of a parallelogram, opposite sides congruent, opposite sides parallel, opposite angles congruent, consecutive angles supplementary, diagonals bisect each other, plus all 4 angles are right angles, and the diagonals are also congruent. Is everybody okay with that? A lot of properties we need to remember. You have to remember which ones are specific to what shapes as well. All right, let's take a look at our picture. We are going to fill in everything that we can fill in before we start answering questions. I usually start with my sides. Do I have any of my sides labeled? Mm-hmm. Yes. So what I want you to do then is I want you to go and fill in the other sides on your picture. Just label it in your picture. We're not trying to answer questions just yet.
Go back up real quick, Ms. Brady.
Bless you.
Real quick, you just go back up. I think I missed the last one. All right, good.
All right, if PQ, my top side is 24, what else is 24?
Bottom side.
The bottom side, okay. And then if PS is 10, what else is 10? The right side, QR, yep. Is that all that it gives us? Yeah, but it's asking me for a lot of other segments, isn't it? Okay, so let's bless you. Fill in what we got. What is QR? 10. And what is SR? 24. Okay. What's the next thing it asked me for? Okay, let's take a look at this. SQ is the entire diagonal, correct? Now, I know it's going to be congruent to the other diagonal, but I don't know what it is yet. Do I know either of my pieces of my diagonals? No. So what we have to do is think a little bit on this one. We know SR, and we know QR, and we know that this is a rectangle, which means down there at R, that big angle is what kind of angle?
Obtuse.
A right angle.
No, you can't. So it could be 90.
No, the angle is 90. We're looking for the segment. Let me ask you this. What kind of shape did I just highlight?
A triangle.
What kind of triangle specifically? A right triangle. So what I'm going to do is I'm going to come over here to the side. I'm going to draw that right triangle. This is S. This is Q. This is R. We know that that is 10. We know that that is 24. And we know that that is a right angle. What we're trying to find is SQ. So we're going to call that X. We've done stuff like this before where we have a right triangle and we only know 2 of the 3 sides. We have to do this theorem to figure out the third side starts with a P. What is it? Pythagorean theorem. So what we have to do is remember the Pythagorean theorem. A squared plus B squared equals C squared. So what we want to do first.
Wait.
I'm talking. I'm explaining. What we want to do first is decide C, the hypotenuse. That is the one directly across from our right angle.
What do we multiply with Bridget?
Nothing yet. Which one is my hypotenuse? In my red triangle that I have drawn. X. Okay. So when we set it up, remember how we do this. We always do our hypotenuse squared is equal to the other 2 sides squared and added together. Okay.
What does that have to do with the number 1? You were working it through it?
Working through it, yes. So what I need you to do is use your calculator, do 100 squared, do 24 squared, and add those together. Ten squared is 100. 24 squared is 576. So if I add those, I get 676. Okay. So what I want you to do now is in your calculator, take the square root of 676. If it is a decimal, we're going to round it to the 10th place. If not, we'll just leave it as it is. If I do the square root in my calculator of 676, do I get a decimal or a whole number? So on this calculator, you're going to hit second, and then the button that says X squared on it, and then you notice you get the square root sign in your screen, and then put the number 676. So to do the square root, you're going to hit second, and then the X squared. Did I get a decimal or did I get a whole number? What number? 26. Okay. So that means SQ, my whole diagonal is 26. So what would the other diagonal PR also be since my diagonals are congruent here? 26, yeah. And then QT is how much of that diagonal? Half, so that would make it, there you go. Okay, so we were given the sides. We can find the diagonal by doing the Pythagorean theorem since it's a right triangle. Both diagonals are the same, and then the other one is half. Hit second, and then your last one here. Okay, put in your number. And then they equal. It's half. It's half. Makes sense? Yes. Okay. Is everybody good? Which part? This one. So hit second first, and then hit your expiration, and it's like square root comes up, and then you do your number, 676.
So when I add them two together,
This is 100. That's 576. So you add them, you do 676.
then the
Everybody okay? Alrighty then. Are we ready? Sure, can't wait. Ready to go. Okay. Number 2, do we have any segment lengths given to us? No. All I have is An angle, thank you. We talked last week about the angles, like alternate interior angles, like this one and this one would be congruent. These two would be congruent, right? The same thing is going to happen in a rectangle. So if this top angle up here at J is 27, which one is also 27? The bottom at L, so this one right here. So we're going to call that 27 as well. So far, so good. Okay. Based on our properties from our rectangle, what measure is this whole angle going to be up here? What kind of angle is every angle in a rectangle? Right angle. Okay, so that means this is going to be 90 degrees. So does that mean I could find that bottom one there? Yeah, because together those two angles should be 90 degrees. What is the top angle? What's the top number next to J? 27. So if I want to find the bottom one, I'm going to subtract it from 90. Oops. I can subtract. It might help. Okay, so that one's going to be 63. Which means, what else is 63? Alternate interior, the top one at L. So far, so good. We got alternate interior angles because of parallel lines. My corner angles in a rectangle make 90 degrees. So what do I add to 27 to get 90? 63. Okay. Hold on. So what I want to do now is think about our picture, and this is where it takes a little bit of thinking outside of the box. We know our diagonals do two things. They do what to each other? Bisect. And then our new property for rectangles said that they are also what to each other? Congruent, yes. So that means this is congruent to that. Okay, the diagonals, because they bisect each other. But then again, because my diagonals are congruent, the other two pieces are all going to be the same as well. Okay, so all four of those are going to be the same length. MN, NK, JN, and NL. The diagonals are congruent and they cut each other in half, which means all four pieces will be equal. Are we okay so far? Let me ask you this. If I look at this shape right here, what kind of what is it? What shape is it? Triangle. But more specifically, if those two sides are congruent, it starts with an I. Isosceles triangle. Do you remember we talked about isosceles triangles before? Kind of, maybe. Hold on. So look at your triangle here. This is M, that's N, that's L. We mark that congruent, we mark that congruent, correct? Yeah. What is this angle down here at L? The bottom angle we said was 27, right? In our picture. If these two sides are congruent with an isosceles triangle, we talked about this before, two congruent sides leads me to two congruent angles. So which two angles would be the same? M and L. So if L is 27, guess what M is? 27. Okay. So let me go ahead and label that in my picture. Bottom one at M. Is 27. So what do you think that top one would have to be next to 27? Oh, I'm not this one. I'm talking about this one, the one next to M in my picture up there. 63. Okay, look at this. This one is 27. We figured that one had to be 63 because they have to equal 90, right? Doesn't this whole one have to equal 90 as well? So if this is 27, then that one is going to be 63. What about the other side? At the top of K, what do you think should go there? 27, yep. And then at the bottom should be 63. In a rectangle, it is going to be like this every time. These two will be the same. These two will be the same. Those two will be the same. And those two will be the same because we technically have 4 isosceles triangles there. So what we want to do is see what they ask us for. See if we have everything filled in. We might have to do a little bit more work. So let's start with MJK. Okay. MJK. Look at M to J to K. Is that one of the smaller angles or the whole corner? The whole corner. So what is MJK going to have to equal? 90. Then we're going to go to MJL. So MJL comes down here. So what the corner, what number did we have that labeled as? 63. MJL. That's going to be 63. What about JLK? Which one's in the corner there? JLK is what? 63. Yep. K M L is in the corner there. K M L is 27. Yep. And then we've got M N L. Do I have that one labeled? No. Okay, so this is where we got to think back. Brian, I think you already told me the answer to this. But it's this angle right here that we're looking for, correct? M N L. How many degrees is a triangle? 180. Well, if I have 2 of them, can I find the third? Yep, so we're going to add the 2 together. And then I'm going to subtract that from 180. And we get 126. So MNL is going to be 126. So a lot of stuff you have to remember to apply it to be able to figure this stuff out. Everybody kind of okay with those? What does it tell me about quadrilateral ABC? It is a what? Rectangle, okay? And then it gives me a little bit of information. What I want you to do is label what it tells you in your picture. So in that picture, what I want you to do is label angle BAC as 3x plus 3. Okay, find angle BAC, label that as 3x plus 3. Then find angle ACB and label that as 5x minus 1. We're just labeling our picture. BAC is 3x plus 3. ACB is 5x minus 1. Everybody okay with where those labels are? Where I put them in my picture? Now, quick question. Are those opposite sides of the transversal? Are those alternate interior angles, or are they on the same side of that line? They're on the same side. Okay, so we can't use the alternate interior angles being congruent. So we're going to have to think about something else. Just the two of them? You're along the right track, but we're missing something. Okay, let's take a look at this. What shape is that? A right triangle, right? And we know that this angle right here is 90. So we wouldn't just do the two of them, we would do... Okay. The yellow is a triangle. Everybody agree with that? And how many degrees are in a triangle? 180. So what should I do with those three angles? I'm going to add them. So 3x plus 3 plus 5x minus 1 plus what else? I need to equal 180, but what's my other angle? Yeah, I got this one. I got this one. The box is 90, so we're going to add 90. And that's equal to 180. Yeah. Okay, all three angles. Okay, do the work. Combine your terms. Solve for x. That's what it's asking us. Do the work. Solve our equation. All right, if I'm starting to do my work, are those x's on the same side of the equal sign or opposite sides? Same side, so we're just going to combine them as they are. What is 3x plus 5x? 3 plus 5? 8. Then I'm going to add a positive 3, a negative 1, and a positive 90. What is that going to give me? Positive 92. I can subtract my 92 over 8x. Thank you. And then if I divide both sides by 8, I get x equals 11. And that's all it asked me for, right? It didn't ask me to plug it back in. It just said find x, right?